How will the universe end in the next centillion years? It's a question so big that it's difficult to wrap your head around. The universe has been around for about 13.8 billion years, and it feels eternal. But it isn't. Like everything else in nature, the cosmos had a beginning, and it will have an end. What might that end look like, especially over unimaginable stretches of time, say a centillion years into the future? This is the problem. To understand how the universe might end, we first need to understand how it behaves now. In 1929, astronomer Edwin Hubble discovered that galaxies are moving away from each other, which means the universe is expanding. Later, in 1998, scientists found that this expansion is actually accelerating because of a mysterious phenomenon called dark energy. This acceleration changes everything about how the universe might end. But before we look at possible scenarios, we need to think about time on a cosmic scale. A centillion years is 10 to the 303rd years. That number is so large it's practically impossible to imagine. For comparison, the Earth is only about 4.5 billion years old. A centillion years is vastly beyond that. What would happen to the universe during that incomprehensible time span? This is where the agitation begins. Let's start in the near future, at least in cosmic terms. In about 5 billion years, the Sun will run out of hydrogen fuel and swell into a red giant star. It will likely engulf Mercury and Venus and maybe even Earth. After that, it will shed its outer layers and shrink into a white dwarf, the dense core of the star that will slowly cool over trillions of years. Across the universe, other stars will go through similar life cycles. Massive stars will explode as supernovae, leaving behind black holes or neutron stars. Smaller stars will end up as white dwarfs. But here's the problem. Stars can't form forever. Eventually, the hydrogen gas that fuels star formation will run out. Scientists estimate that about 100 trillion years from now, star formation will cease. The stellar era, the bright active phase of the universe, will end. What comes next? The degenerate era begins. White dwarfs will cool and fade into black dwarfs. Neutron stars will sit in the dark. Black holes will dominate the universe. But even black holes don't last forever. In 1974, physicist Stephen Hawking discovered that black holes lose mass over time through something called Hawking radiation. This process is incredibly slow, but it means that black holes will eventually evaporate. For the supermassive black holes at the centers of galaxies, this will take an extraordinary amount of time, about 10 to the 100 years, or 1 Google years. But we're talking about a centillion years, 10 to the 303rd years. By that point, every black hole in the universe will be gone. So what's left? We'll enter the dark era. The universe will be a vast, cold, and empty place. If protons decay, something physicists still aren't sure about, all matter will eventually break down into radiation and elementary particles. Estimates suggest proton decay, if it happens, could take up to 10 to the 36th years. If protons do not decay, the universe will simply be filled with lonely remnants, dead planets, black dwarfs, and subatomic particles drifting farther and farther apart as the universe continues to expand. And this expansion is another problem, because the universe isn't just expanding, it's accelerating. If the acceleration of expansion continues at its current pace, we're heading for what scientists call the Big Freeze. Galaxies will move so far apart that no light from one galaxy will ever reach another. Stars will burn out, energy will even out, and the temperature of the universe will approach absolute zero. But there's another, even more extreme possibility: the Big Rip. In this scenario, dark energy doesn't just keep expanding the universe, it gets stronger. If it becomes powerful enough, it could overcome all the fundamental forces holding matter together. Galaxies, stars, planets, and even atoms would be torn apart. If this is the universe's fate, it would end much sooner than a centillion years from now. There's also the Big Crunch hypothesis. This was once the leading idea before we knew about dark energy. It suggested that gravity would eventually stop the expansion of the universe and pull everything back together into one dense singularity, the opposite of the Big Bang. But because the universe's expansion is accelerating, the Big Crunch now seems less likely. So, which scenario is most probable? Based on what we know now, the Big Freeze, or heat death, is the most likely fate. Based on what we know now, the Big Freeze, or heat death, is the most likely fate. In this outcome, the next centillion years will see the gradual extinguishing of everything we know. Stars will die, black holes will evaporate. Matter may decay, and the universe will be reduced to a thin soup of radiation and elementary particles spread so far apart that they will rarely, if ever, interact. It's a bleak picture. But here's the solution, or at least perspective. The end of the universe is unimaginably far away. A centillion years is such a huge timescale that it's effectively infinite from our point of view. We don't need to worry about the heat death of the universe. It's not going to happen in any time frame we can relate to. What we can do is reflect on what this tells us about our place in the cosmos. We are living at a rare moment in cosmic history. Stars still shine, galaxies are active, planets orbit their suns. Life exists, at least here on Earth. Billions of years from now, this vibrant era will be gone. Thinking about the end of the universe also shows us how much we still don't know. We don't fully understand dark energy. We don't know if protons decay. We don't know if there might be other universes beyond our own, with different laws and different fates. And that uncertainty is not a reason to despair. It's a reason to keep exploring. Because while the universe will end one day, it's alive with activity right now. And the knowledge we gather today could help us understand not only where we came from, but how we might preserve life for as long as possible. So, how will the universe end in the next centillion years? Most likely, it will grow colder and darker as the Big Freeze sets in, but it might be ripped apart, or it could collapse back into a singularity. We simply don't know for certain. What we do know is that we're here now, in a universe that is full of energy and light. And that's worth appreciating, because the real question isn't, how will the universe end? The real question is, what will we do with the time we have in it?